Good day, sir. This is Elyn Doloritos from BS Mathematics, second year student. Today, I'm going to present to you the history of calculus. First is the history of calculus consists of several phases. The first one is the prehistory, which goes up to the discovery of the fundamental theorem of calculus. It includes the contributions of Eudoxus and Archimedes on equations, as well as research by Fermat and his contemporaries like Cavalieri, who in modern terms computed the area beneath the group of functions like x to the power of r for rational values of r not equal to -1. Calculus, as we know, it was invented by Leibniz. Newton's theory of fluxions is equivalent to it, and in fact, Newton came up with the theory first, using results of his teacher Barrow, but Leibniz published them first. The dispute over priority was fought out between mathematicians on the continent, later on including the Bernoullis and the British mathematicians. Essentially, all the techniques covered in the first courses on calculus, and many more like the calculus of variations and differential equations, were discovered shortly after Newton's and Leibniz publications, mainly by Jacob and Johann Bernoulli, the two brothers, and Euler. There were of course a lot of other mathematicians involved, L. Hospital, Taylor. As an example of the analytic powers by Johann Bernoulli, let us consider this evaluation of integral from 0 to 1, x to the power of x dx. First, develop into a power series, then exchange the two limits. The power series is a limit, and the integral is the limit of Riemann sums. Integrated the individual terms, integration by parts. Exchanging limits, transforming power series, even those converging only conditionally, and similar techniques were used without justification. The foundations of the calculus were shaky. To say the least, neither Newton's fluxions nor Leibniz's infinitely small quantities could be given a precise definition. Bishop Berkeley published a famous manuscript in which he pointed out these shortcomings and claimed that calculus was as much based on faith as was theology. The mathematicians were aware of these problems, but still were mainly concerned with inventing methods for applying calculus. Lagrange, Fourier, Laplace, Gauss, Stokes, Grange, Jacobi refined and extended analysis and applied it to problems in celestial mechanics and physics. Making analysis rigorous was a long process that started in the 19th century, the main contributors being Cauchy, the precise notion of limit, Abel, Dirichlet, Riemann, Weierstrass, and the construction of the rail using Dedekind cuts, and Bolzano. Phase 4 involved mathematicians such as Cantor, or set theory, construction of the rails using Dedekind cuts, and Bolzano with Cauchy's sequences. Beer and Lebesgue analysis became abstract and used set theory in an essential way. That's all, and thank you so much, sir.